Welcome to The Explainer. Today, we're going to pull back the curtain on a piece of technology that is, honestly, the secret sauce behind so much of our digital security. We're talking about everything from sending secret messages to logging into massive cloud servers. And it all starts with a tale of two keys. So let's just dive right in with this question. Because this is at the absolute heart of how we trust anything on the internet. We all do it 100 times a day. But how does it actually work in a way that's genuinely secure and not just, a password that can be guessed? Well, to answer that, we have to get our heads around this really brilliant idea called asymmetric cryptography. And the main thing to know is that instead of having one key that both locks and unlocks something, like your front door key, here we have two totally separate keys that are mathematically linked. Yeah, so this is where it gets a little weird compared to a physical key. You've got a public key that you can share with literally anyone. Post it on your website, email it to friends, whatever. And then you have a private key that you protect like it's a state secret. They're designed to do opposite jobs. And the math is so clever that you just can't figure out the private key even if you have the public one. Okay, to really get a handle on this, let's just forget about all the code and computers for a minute. Let's imagine we have a special kind of box with a very, very unique lock. I promise this little story is going to make everything click into place. So picture this lock. It starts at the 12 o'clock position, straight up and down. That's unlocked. Now, you can turn it in two different directions to lock it. You can go left to the 9 o'clock position, or you can go right to the 3 o'clock position. But here's the twist. You need different keys to turn it in different directions. You have one single, solitary, private key. You guard this thing with your life, and it can only turn the lock clockwise. Then, you've got your public key. You can make 1,000,000 copies of this thing, hand them out like flyers at a concert. This key can only turn the lock counterclockwise. Got it? Two keys, two directions, one very special lock. Okay, so we've got this weird box and these two different keys. What's the big deal? What can we actually do with this setup? Well, it turns out this simple system gives us two superpowers online: the ability to send secrets and the ability to prove who we are. Let's tackle secrecy first. Say I want to send you a secret message. I grab one of your public keys. Remember, you've handed them out to everyone. I put my message in your box, and I use your public key to turn the lock counterclockwise. And bam, it's locked. Now, here's the cool part. My public key can't unlock it because it only turns one way. In fact, no public key can unlock it. The only key on the entire planet that can open this box is your private key. And this, right here, is the digital version of what we just described. Alice wants to send a secret. That's the plain text input. She uses Bob's public key to scramble it into what we call ciphertext. Now that message could be flying across the open internet, but it's just gibberish. The only thing that can unscramble it is Bob's private key. That's confidentiality. Okay, now for that second superpower. What if you do things the other way around? What if you lock the box, but you use your private key, turning it clockwise to the 3 o'clock position? Well, now anyone with your public key can open it. This isn't about secrecy, it's about proof. Because think about it, if I can use your public key to open this box, that is undeniable proof that it could only have been locked by your one-of-a-kind private key. And here's the techie view of that. Bob signs a message using his private key. He sends it out, and anyone, Alice, Mike, anyone, can use his public key to check it. If their public key unlocks the message, they have mathematical proof that it came from Bob and that it hasn't been tampered with. This is the whole idea behind a digital signature. It's all about authenticity. Okay, so we've had our fun with the box and key story. Let's bring this back from the world of analogies and plug it into the real world of bits and bytes and actual computers. And what's so cool is how perfectly it maps over. That box we were talking about? In reality, it's a cryptographic algorithm, a set of math rules, like the famous RSA algorithm. And the keys, they're not metal, they're just really, really big numbers with special properties. The message can be anything digital. We're just swapping physical objects for mathematical ones. So where do you actually see this stuff in the wild? Well, a perfect everyday example, one that tons of developers use constantly, is when you log into a remote server, maybe an AWS EC2 instance in the cloud, without even using a password. The goal is simple. We want to use our key pair to prove to the server who we are. We're basically using that digital signature trick we just talked about. And this makes logging in not just more convenient, but way, way more secure than any password you could think of. And the setup is actually pretty straightforward. You run a little command on your own computer to generate the key pair. Then you copy the public part, never the private part, over to the server. The server just adds that key to a list of allowed keys. And that's it. From now on, whenever you try to connect, the server will basically say, "Oh, it's you. Prove you have the matching private key," and your computer handles it all automatically. And this is the bottom line, really. This isn't just a slightly better password. The math behind these keys provides a level of security that even a ridiculously long and complex password just can't compete with. It's a whole different ballgame. So let's just boil it all down. This whole two-key system, this asymmetric cryptography, it gives us two incredible powers online. When you lock with the public key, you get secrecy. When you lock with the private key, you get authenticity, proof of who you are. And those two things are the absolute bedrock of modern digital security. Now that you know the principle of the box and the two keys, I guarantee you're going to start seeing its influence absolutely everywhere, from that little padlock icon in your browser to the way your apps update securely. It's all built on this foundation. Thanks for watching.